Given a complex number in polar form, z equals 2 times the quantity cosine pi over 6 plus I sine pi over 6, we want to find z to the fifth using z equals r times e to the power of I theta, or the exponential form of a complex number. We just did this exact same problem using de Moivre's theorem stated here, but I also want to show how we can use the exponential form of a complex number as well. So because the complex number is given in polar form, we should recognize that r is equal to 2 and theta is equal to pi over 6. So the given complex number in exponential form would be z equals 2 times e raised to the power of I times pi over 6, or pi over 6 times I. So if we want z to the fifth, we'll just raise both sides of the equation to the fifth power. Now remember, the exponent on this 2 is 1, so because we have powers raised to powers, we're now going to multiply the exponents. So we'll have 2 to the fifth power, and then e to the 5 times pi over 6i, which would be 5 pi over 6i. Now let's go ahead and write this back in polar form. Now r is 2 to the fifth, and theta is 5 pi over 6. So we'd have z to the fifth equals 2 to the fifth times cosine 5 pi over 6 plus I sine 5 pi over 6. Notice this is the same result as if we applied de Moivre's theorem, but instead we use the exponential form of a complex number. So now we have 2 to the fifth, which is 32. Let's go ahead and use the unit circle to find the value of cosine 5 pi over 6 and sine 5 pi over 6. Here's 5 pi over 6 radians. So the cosine function value is negative square root 3 divided by 2, and the sine function value is 1/2. So we have negative square root 3 divided by 2 plus I times 1/2, or 1/2 I. 32 is divisible by 2. This will be negative 16 square root 3 plus 16i. This is our complex number raised to the fifth power using the exponential form of a complex number. So if you watch the other video, I hope you can see the connection between de Moivre's theorem and the exponential form of a complex number. Thank you for watching.